Hi everyone, this is Mr. Zhang, and today we'll be going over the math homework for Class P. This is for session U10. Alright, for question number 1, what is the value of A if 5A minus B minus C is equal to 36, and B is equal to C is equal to 1/2 of A? So you have 3 variables and 1 equation in here, so it's kind of like a non-starter. You can't even solve for that because in order to solve for 3 variables, you need 3 equations. Now, fortunately, we know that B is equal to C is also equal to 1/2 A. So that means that the other 2 equations are actually here. B is equal to 1/2 of A, and C is equal to 1/2 of A as well. So now you actually have 3 equations and 3 variables. You're going to do 2 substitutions. You'll replace B with 1/2 of A, and you will replace C with also 1/2 of A, because they just happen to be equal. So then you can actually solve for A. Instead of 5A minus B minus C, you actually have 5A minus 1/2 of A, and then minus another 1/2 of A. And notice they're all like terms, and that's still equal to that 36 on the right. And now because they're all like terms, 5A minus 1/2 of A and minus 1/2 of A all combine. So you really just have to do 5 minus 1/2 and minus another 1/2, which leaves just 4A. And that's going to be equal to 36. And then if you divide both sides by 4, you will get that A is equal to 9. So the answer is choice B. So again, for number 1, you have a system of equations, and you just have to do 2 substitutions to solve. Well, to get everything to 1 equation, 1 variable, which will allow you to solve using inverse operations. Okay, for question number 2, if a given number is divided by x and the result is 5 times the original number, what's the value of x? So for this question, it's actually you gotta turn a word sentence into a number sentence. So the word sentence says you have a number and you divide it by x. So n, which is some number, and you divide it by x, and then the result is gonna be equal to 5 times the original number, which is n. So we call the original number n, and we call, x is x. We have the equation n divided by x is equal to 5n. And here you actually want to find out what's the value of x. So right now x is in the denominator. You don't want that. So to make x not in the denominator, you can actually multiply both sides by x. They'll cancel out x on the left side, and that'll give you n, which is equal to 5 times n times x on the right. Then you can divide both sides by 5n, because the goal is to figure out what x is. X is the variable of interest. So to solve for x, you can divide by everything else on the right side. And that means that you have to also divide by 5n on the left. And n actually cancels out. Now you still have a coefficient of 1. Remember, if you don't see anything, there's an invisible 1 in front of the variable. That's the coefficient. So instead of writing 1n, you can just write n. But the coefficient of 1 is really there. It's really 1 times n. Anything times 1 is equal to itself. That's just the identity property. So if you write that 1 in, it actually really helps, because then you have x isolated on the right, and you have 1/5 left on the left side. So you know that x has to be equal to 1/5, which is choice A. All right, next for question number 3, a certain line segment in a rectangular coordinate plane, so just a regular XY plane, has endpoints A and B, and is perpendicular to the y-axis. If point A is located at -2, -3, which of the following could be the location of point B? So rectangular coordinate plane is just a regular XY coordinate system, the Cartesian plane. Now, A and B is a line segment, I should say, and it's perpendicular to the y-axis. So perpendicular means 90 degrees. So it forms that letter T, or plus sign. So the y-axis is running up and down, and you want to be perpendicular to that. So that's going to look like this. Now, one of the points is that -2 comma -3. So that's actually here in quadrant 3. And you need it to be perpendicular, so it has to go this way. So it looks something like this. Now, you don't know where the other endpoint is. But you do know that it needs to have the same exact y value as the y value of point A, because if this line segment is perpendicular to the y-axis, then it has to lie on the line y equals -3. And that's a horizontal line that is perpendicular to the y-axis. So go through all the choices. If you scan all the choices, only choice E has the same y-coordinate of -3. So that means that the answer has to be choice E. So B could be 2 comma -3. Again, it could be anywhere on this line. So it could be 3 comma -3, 5 comma -3, but it has to have a y coordinate value of -3. All right, next for number 4, if 4 used books cost $9, what is the cost in dollars of 20 used books at the same rate? So the keyword here is rate. So you know that 4 books is equal to $9. And you want to know how much do 20 books cost. So you want to put 20 books underneath books that have the same units. And that'll cost, let's say, X dollars. And you want to solve for X. So because we can use the same rate, we can just use unit rates here. We can also use proportions. But here, you know that 4 times 5 is equal to 20. So then you also have to multiply the other side by 5. And that means that X will be 9 times 5 or $45. And that's choice D. You can also solve this using a proportion. That would be 4 over 20 is equal to 9 over X. And that allows you to cross multiply to get 4X equals 20 times 9. And then you could just divide both sides by 4. And once you do that, 20 and 4 cross cancels. You get 5 and 1. And 5 times 9 is the same, 45. All right, next for number 5, if A minus B is equal to 0, which of the following is equal to A times B? So you know that A is equal to, A minus B is equal to 0. And from here, you can add B to both sides. And that allows you to cancel out the negative B on the left, which will give you A is equal to B. So if A is equal to B, then A times B would really just be equal to A times A, because you can replace B with A, or you can also do B times B. So either way, you will get A squared or B squared. They're all the same thing. Now, we do see choice C as A squared here, so that would be the answer. All right, for number 6, if 5 times the square root of z is equal to 30, or minus 30 rather, is equal to 2 times the square root of z plus 54, then z is equal to, all right, so we have this really big equation, and a couple things you have to do. You have z underneath the radical sign, so that's annoying. You're going to have to isolate the square root of z. Because if you isolate the square root of z, then you can square it afterwards to get rid of the annoying square root symbol, because that's the inverse operation. But you have to clean this up first, so that requires adding 30 to both sides. So if you add 30 to both sides, I'll cancel out the negative 30 on the left, and that'll give you 5 root z on the left is equal to 2 root z, or 2 times root z plus 84. right? And then next step, it turns out that because both of these are square root of z, they're actually like terms. So this is a like term with this. So just like if you have variables on both sides, you're going to move them to one side. So you'll have to move 2 times root z to the left, and that means you can subtract 2 times root z to both sides. And 5 root z minus 2 times root z is equal to 3 times the square root of z. And that's equal to 84. All right, so again, there's a small little dot there, which means multiply. So the opposite is divide. So once you divide by 3, you get that the square root of z is equal to 28. And now we've isolated z. So what you're going to do, you're going to have to square it afterwards. So you're going to have to square both sides. So when you square both sides, that will actually cancel out the square root because they're inverse operations. So that will give you z is equal to 28 squared. So I don't know what that is. So you'll have to multiply 28 times 28. All right, and you get your z, 784. All right, so for number 6, you have to isolate the square root of z by combining like terms, and then you have to square both sides to solve for z. All right, next for number 7, the measures of 2 of the 6 angles of a hexagon are 120 and 80 degrees. What is the average arithmetic mean of the measures of the remaining 4 angles? So you have a hexagon, and 2 of the angles are 120 and 80. Now you want to know the average of the remaining angles. So it really helps if you know the sum of the angles of this hexagon. So that requires you to actually use either a formula or just a little trick that I'm going to show you guys. So the formula here is one way that you can remember this. So if you want to know the total sum of the interior angles of an n-sided polygon, the formula is n minus 2 times 180. Now, here for this hexagon, we know that n is equal to 6. So for hexagons with n equal to 6, you'll just substitute in 6 for n. So that will be 6 minus 2 times 180, or which is equal to 4 times 180, which will be equal to 720. Now, the other way to do this is to just draw any hexagon. And the goal here is to pick a point and then connect this point to all of the other corners that you can. And each of the corners, or each of these lines, will make a triangle. And each triangle, is 180 degrees. So that's really where we get that 4 times 180 from. You can actually break this hexagon into 4 triangles, and each triangle is 180. So 4 times 180 is 720. So that's the other way to do this, but the formula is really helpful, so I would definitely memorize that. Anyway, so once you know that the total should be 720, 2 of them are 120 and 80. So, again, not drawing a scale here, but that's about 120 degrees, and 80 degrees looks kind of like this. So the other one just kind of looks like that. I don't know, whatever. The other 4 angles, so 1, 2, 3, and 4. You want to know their total. Well, 120 plus 80 happens to be 200. And the total has to be 720. So minus that 200 that you already have, it's going to be 520. So that 520 represents the remaining 4 angles. All right, now you want to find the average. So remember, average is the total divided by the number of data, in this case, the number of angles. So that's going to be a total, which is 520, divided by 4. And that's going to be 130. That's choice C. So here, just to quickly summarize, you do need a couple of formulas here, specifically the sum of the interior angles of inside the polygon. It's given by the equation n minus 2 times 180. So you can use that method to get the total angles, the total sum of the angles, and then just subtract to find the total of the remaining angles over here, and then just divide to get the average. The other way is to just draw the shape and then just draw smaller triangles in it. All right, next for number 8, you have 5 times, in parentheses, x to the 4th, y to the negative 5th, z to the 6th, close parentheses, and then through third power. All right, so here you have to do order of operations. First, to just simplify this or expand this in some way, to just rewrite it rather. Now, you could use a couple of laws of exponents. First one, see a negative exponent there. So with negative exponents, b to the negative a is equal to 1 over b to the a. So this is one of the laws of exponents that states that if you have a negative exponent, you have to do a reciprocal. You have to flip the fraction upside down. So that's something we're probably going to have to use here specifically. And then once you use that, instead of y to the negative 5th, this will turn into 5 times parentheses, x to the 4th. You can put little multiplication symbols there if you want. And you'll have to do 1 over y to the 5th. So if right now it's in the numerator, it'll flip into the denominator. And you're still multiplying by z to the 6th. And then you're raising this to the third power. Now, the other two exponents here don't have a denominator, so you can put them over 1. So you can just rewrite this as 5 times parentheses x to the 4th times z to the 6th divided by y to the 5th. And this is being raised to the third power. Now, you're going to have to do that part first. Right? You have to do exponents before you multiply by the 5 outside. So multiplication happens after exponents. Remember, please excuse my dear Aunt Sally. We did the parentheses already, inside the parentheses over here. So now you have to do the exponents. Now, for the exponent part, you can actually use the law of exponents that states that b to the a to the c is equal to b to the a times c. And so you have to multiply power to power. And if you have a fraction inside the exponent, let's say a over b, and you're raising this to the c power, because we have a fraction in there, this will turn to a to the c divided by b to the c. You have to apply this exponent to everything inside the fraction. So we'll have to use both of those laws as well. So do that law, you will just apply this, take this 3, and just apply it to the 3 things inside the parentheses. And that'll give you 5 times x to the 4th to the third power times z to the 6th to the third power, and divided by y to the 5th to the third power. And then you can use this law of exponent here to do a power to power. So you have to multiply those 3 pairs. So this will turn into 5 times x to the 4 times 3, or 12, and z to the 6 times 3, which is 18, divided by y to the 5 times 3, or 15th. Now 5 doesn't have, so now you can finally multiply the 5. 5 doesn't have a denominator, so you can write this with the denominator of 1. So this will turn into essentially 5 times x to the 12th, z to the 18th, divided by y to the 15th. That is choice B. So to do question number 8, you have to do the order of operations as always, but you also have to utilize some laws of exponents. A negative exponent means reciprocal. Power to a power means you have to multiply the exponents. And finally, if you have a division inside of parentheses being raised to that exponent, you have to apply the exponent to everything inside the parentheses, in the numerator and also the denominator. Next, for question number 9, one painter can paint 2 identical rooms of a certain size in 90 minutes. If a hotel has 50 of these identical rooms, how many painters working continuously at this rate are needed to paint all the rooms in the hotel in 7.5 hours? All right, so we have a couple of units here. You have painters. You also have rooms, which is this job or this work, and you have a time here, which is in 90 minutes. So there's a formula that you can use. It's actually a variation of the distance formula. It's called the work formula, which is just work equals rate times time. So that's the starting point here. It's the work formula. The same idea as the distance formula, except you're doing some work, painting some rooms. Now, you can paint 2 rooms in 90 minutes. So that's a rate. So that means that you can paint 1 room in 45 minutes. Because time and number of rooms painted, they're directly proportional. So you can just, divide by 2 on the left side, divide by 2 on the right. So that's the idea. Now, you need multiple workers to paint this entire hotel. So here, if you have 1 worker, that's equal to 1 room in 45 minutes. When you bring in the worker or the people doing the job, it becomes a little different because the more people you use, as the number of people go up, the time it takes to paint the entire hotel actually goes down, assuming that the rooms stay the same. That's because you have more people working together, the time will decrease. So we call this inversely proportional. Because one of the quantity goes up, the other one goes down. So you got to be careful there. It's not directly proportional, it's inversely proportional here. All right, so here, that 1 worker has to do 1 room in 45 minutes. So if you need to do, let's say, 50 of these rooms, if you have 1 worker to make 50 rooms, it'll take 45 times 50 minutes. So that's just the first part. Number of rooms and time, they're directly proportional. The more rooms you have, the more time it'll take that 1 worker to paint them. So here, 45 times 50. That's 2250 minutes. And you can do 2,250 divided by 60. So you can cross out the 0. And 6 goes into 45 7 times. That's 37 3/6, or 37.5 hours. Now that's for 1 worker. So of course that 1 worker will take forever to paint all the rooms on himself. But fortunately, you can have multiple workers here. And you want to decrease this rate to 7.5 hours specifically. So from here, if you take 37.5 and let's say you double it, you'll have this. If you double 37.5 times 2, you'll have 75 hours. But remember that you have to divide by the number of workers. So it'll take like half of a worker. Uh, 75 hours to paint 50 rooms. So half worker, half doesn't make any sense. But we're just using this as unit rates. Now, what we're gonna do now is 75 can go. The reason I doubled it to 75 is because you can turn 75 to 7.5 if you divide by 10. So 75 divided by 10 is 7.5 hours, which is what you want. And now, because they're inversely proportional, again, it's inverse. Since you divided the right side by 10, you're gonna have to multiply by 10, and 1/2 times 10 is 5 workers. So 5 workers will take 7.5 hours to paint 50 rooms. That's choice D. So just be careful in terms of directly proportional and inversely proportional rates. Essentially, if you have the work equals rate times time equation over here, and if you throw in the number of workers, the way you solve for this is just like solving any other unit rate. The only difference is you have to be careful which factors you multiply and which ones you divide if this is an inversely proportional relationship. Because time and rooms, or time and work, they're directly proportional, but worker and time, they're inversely proportional, so you just have to be careful there. You can only change 2 at a time anyway. All right, and here's the summary for this page. All right, next for number 10. Random 2-digit integers can be generated using 10 cards numbered from 0 to 9. A card is drawn at random from 10 cards. That number is recorded as the first digit of the 2-digit integer. The card is replaced, which means put back in the deck, and the card is again drawn at random from 10 cards. And this number is recorded as the second digit of the 2-digit integer. The first card drawn is 2. How many prime 2-digit integers can result? So you're just making 2-digit numbers. The first one you redrew is a 2, but you put back in the card, put back in the deck. So all the 10 cards are back. Basically, here you can draw anything from 0 to 9, and you want to see how many of them are prime. So the only prime numbers in the 20s are 23 and 29. So the answer has to be choice A. Next, for number 11, if x is greater than 0, you want to solve and simplify 4x squared minus 6x minus 40 divided by 6x squared minus 14x minus 40. So here, in order to solve for or simplify these polynomials, you have to actually first factor out a couple of numbers. So just to make the problem easier. So from the numerator, they all have a factor of 2 in common. So you can take out 2 from the coefficients. I'll give you 2 times parentheses, 2x squared minus 3x minus 20. And from the denominator, you can also take out a factor of 2. So that'll be 2 times parentheses, 3x squared minus 7x minus 20 as well. So the 2's will cancel out, and then the numbers just got a little smaller, which is a lot better. Now, you have to factor this. There's no way that you can, divide them, part by part or separately or anything. You have to divide. And when you divide, where the first number is, this first number here, is not equal to 1, it's kind of annoying. You actually have to use a factor by grouping method. So I'm going to turn this into two different polynomials. And that means you're going to have to actually multiply and find factors of the a times the c terms. So if you have ax squared plus bx plus c, you have to take a and take c, multiply them, and look for factors there. So here, 2 times 20 is equal to 40. So you want factors of 40. That's 1 and 40, 2 and 20, 4 and 10, and 5 and 8. So out of those pairs, you're going to have to find some of them that actually combines to get that -3. So 2 times the 20, again, is 40. These are the factors here. And you want to break them down to have that -3x. So you see that -3x come in right here. This 5 and 8. Because this is actually negative, you can get -3 by doing -8 and +5. So you'll rewrite 2x squared minus 3x minus 20 as 2x squared plus 5x minus 8x. And this is how you get that -3. That middle term there. And you still want to subtract the 20. Now from here, you can factor each part individually. So you can factor out the x from the first one, which will be x times 2x plus 5. And from the second term, you can factor out a -4. And that will give you 2x left and another +5. Because -20 divided by -4 is +5. So that means that one of the factors will be 2x plus 5, because now you can take this out, which will give you 2x plus 5 as one of the factors. And the other factor is actually x minus 4. When you factor out the 2x plus 5. So that's how you would do factor by grouping. The numerator is now 2x plus 5 times x minus 4. Now, you should always double check your work, because factoring is always like a guess and check. So just FOIL it. You get 2x times x, which is 2x squared. Double check it on the bottom. You get 2x squared, that's first. And the outer is 2x times -4, or -8x. The inner is +5 times x, or plus 5x. By the way, that's where you get these two from. And the last is +5 times -4, which is -20. And +8x minus 5x and +5x with the -8x, are like terms. So you get 2x squared minus 3x minus 20, which is exactly what you have right over there. So essentially we're just working backwards, because you see that expanded form over there. So the numerator turns into 2x plus 5 times x minus 4. All right, now we just have to do the same thing for the denominator, which is here. So for the denominator of 3x squared minus 7x minus 20, you'll do the same thing. You want to multiply the 3 and the -20. That gives you -60. So now you have to look for factors negative 60, which is 1 and 60, 2, 30, 3, 20, 4, 15, 5, 12, and then 6, 10, and that's it. And now you want a sum or difference of negative 7. So the only one that's 7 away are here, 5 and 12. So because you have a negative 7, that means it has to be negative 12 and positive 5. So you'll break down this negative 7x as positive 5x for this positive 5 and negative 12x for this negative 12. And you still want to subtract 20. So that's that expanded form. Now you'll take each of these separately and factor. So you can factor out x, and that'll give you x times 3x plus 5. Then from the second term, you can factor out a negative 4. So you have x times 3x plus 5 minus 4 times positive 3x plus 5. And now you can factor out this 3x plus 5. So you have 3x plus 5 as one of the factors, and the other factor will be x minus 4. Now, just like before, check by FOILing. So you have first outer, which will be 3x squared minus 12x, and then inner last, which is plus 5x and minus 20, which is exactly what we had over here. And combine like terms, you have 3x squared minus 7x minus 20. So that means that everything does check out. So the denominator is going to be 3x plus 5 and x minus 4. And notice that the x minus 4s will cancel out. So you have choice C left over, 2x plus 5 divided by 3x plus 5, which you can't cancel anymore because you can't factor anything out. So the trick here for what we did was a strategy called factor by grouping, and you only do the strategy only when the A term is greater than 1. For ax squared plus bx plus c, which we had to do multiple times here. Other than that, you wouldn't use factor by grouping. All right, next for number 12, in the figure above, if RS is equal to 12, ST is equal to 6, and TU is equal to 8, what is the distance from the center of the rectangle solid to the midpoint of RS? So here you have to get the distance from the center of the rectangle, which is not shown, so it's kind of there. It's inside the solid, but you want to extend it outwards to get the distance from the center to RS. So that means you'll actually have to draw a right triangle. And that distance is that right triangle. This right triangle kind of goes into the triangle, into the prism here. You have to be careful. Remember, this is a 3D figure. So this line is on the surface. It's the same as this line here. That's just half, so it's supposed to be half. Yeah, we're not drawing a scale, so this would be 3, and this piece would be 6. So that means this piece is 3. Now this piece on the bottom can be drawn this way, where this piece, the bottom, is half of that 8. So it's only going to be 4. All right, so, and those are the other lengths. So here you essentially have a 3, 4, 5 special right triangle, because this piece that's diagonal would have to be 5. So the answer would be choice B. But the key here was to kind of draw these different shapes to figure out that the triangle in question is really just a 3, 4, 5 right triangle. And it helps if you make everything kind of think in 3D. And yeah, so that's how you would draw this triangle. Right, so that's how you would have to kind of picture this rectangle if you just were to cut it into different sides. All right, next for number 13, if f of x is equal to 3x minus 9, what is the value of f of 7 plus f of 5? So this indicates your function, and a function is just an input-output machine. So for this input-output machine, you put an x to the machine, f, you get some output, which is y. Now this rule tells you to do this, and this rule is you multiply by 3, because it's 3 times x first, order of operations, and then step 2 is minus 9. So just have to follow these rules. So for f of 7, you're putting in 7 into the machine. So that means everywhere you see x, you replace it with 7. So f of 7 is equal to 3 times 7 minus 9, or 21 minus 9 is equal to 12. All right, so this piece is equal to 12. And then for second part, you'll replace x with 5. So f of 5 is equal to 3 times 5 minus 9. That's equal to 15 minus 9, or negative 6. Oh, sorry, positive 6. So then 12 plus the 6, because you're still adding here. We're still adding these numbers. So that's going to be 12 plus 6, or 18. Now, I don't see 18 here, because this isn't actually equal to 18. This is saying 18 put into this function. So you actually have to go through all the choices, multiplying by 3, and then subtract 9. So you have to do 3 times 2 minus 9, which is 6 minus 9. That's equal to negative 3, so that's wrong. The next one is 3 times 3 minus 9, which is 9 minus 9, that's 0. For choice C, it's 3 times 9 minus 9, which is 27 minus 9, which is equal to 18, and that's what we're looking for. So the answer has to be C. Essentially have to go through all the choices and substitute in, because each of the choices are also functions. All right, next for number 14, the length of a line segment with endpoints M and N is an integer less than 12. Point L is the midpoint of MN. Point O is a midpoint of ML, endpoint P is the midpoint of Ln. Which of the following could be the distance between O and N? So you have a line segment with M and N. And it's an integer less than 12, so it's shorter than 12. Now L is the midpoint here, and then O is the midpoint of ML. And then finally P is the midpoint of LN. Now, what could be the distance between O and N? Well, here it has to be less than 12. So just pick a number less than 12. Let's say 10. So this whole piece is, well, actually it's split into 1, 2, 3, 4 pieces. So let's not say 10. Let's pick something that's a multiple of 4. So let's say 8. If that's 8, each of these pieces would be 2. So then O to N would be 6. So that's choice E. And it could be the distance, so that's fine. Remember, it has to be an integer, which means it's a whole number. And because it's divisible, it's divided into 4 equal pieces, 4 halves. It has to be a multiple of 4. Okay, next one, number 15. In the figure above, G is the midpoint of FH, and EF is perpendicular to FH. If angle EGF is congruent to angle JFH, and angle FJH is congruent to angle FEG, what is the perimeter of triangle EFG? All right, so G is the midpoint of FH. So midpoint means these two pieces are equal. Statistically also equal to 3. Remember, figure not drawn to scale. And then EF is perpendicular to FH. So that means that you have a right angle here. And then angle EGF, so this angle here, is equal to angle JFH. So we know that this little triangle here is isosceles. And angle FJH, this angle here, is congruent to angle FEG. So it's equal to that angle. All right, and you want to know the perimeter of triangle EFG. All right, so here, you want to fill out these triangles, and first thing that you can do is so here you have a lot of congruent triangles here. That's what this symbol means. They are congruent, or congruent angles, which actually allows you to figure out that these triangles are going to be at least similar. So, for example, for triangle EFG, this angle is corresponding to this angle here, and you have angle EGF, which is this angle, which corresponds to this angle up here. So both of these triangles, if you actually flip, so if you flip it, any of these triangles, or one of these triangles, then it looks more like the other one, you're going to see that they are totally similar. So because they're similar triangles, they have proportional sides. And all you need are actually two angles to be congruent in order to have a similar triangle. That's the AA theorem. So it's the angle-angle theorem. If you have two triangles, you know that one angle's equal to the other angle, corresponding angle, and the second angles corresponds to another second triangle's angles. All three angles are going to be equal because they have to add up to 180. So here, if you look at this angle F up here is 90 degrees. That means that the bottom one also has to be 90 degrees. You have two right triangles. And specifically for the top triangle, it's, it's the sides equal to 3. For the bottom triangle, this part is equal to 6. And these are corresponding sides. So the bottom triangle is 2 times bigger. Now, the base of the bottom triangle here is 8. So that corresponds to the top here. It's going to be half of that, or just 4. So the top triangle is the right triangle. That's going to be a 3, 4, 5 special right triangle. So the perimeter triangle EFG is going to be 3 plus 4 plus 5, or 12. Choice A. So if you want to draw this more to scale, you have a 3, 4, 5 triangle on the bottom. That's actually a double, which is a 6, 8, 10 Pythagorean triplet. And then the triangle on top is just a 3, 4, 5, but got flipped. So 3, 4, and then this piece is 5. So that's more to scale of what this looks like. So for number 15, it's a little tricky, but you get two similar triangles, and for similar triangles, the sides are proportional. So once you know the sides are proportional, you can actually figure out the sides, because both of these turn out to be right triangles, which you can use the Pythagorean triplet or the Pythagorean theorem, a squared plus b squared equals c squared. The triplets are shortcuts to this relationship, and you have 3, 4, 5, and the multiple 6, 8, 10 for number 15. All right, next for number 16, a certain bacterial cell culture under study quadruples its population every 5 days. The example started out with 3 cells. Which of the following expressions would give the population of this culture after 35 days? So it doubles every 5 days. And you have 35 days, so there will be 7 doubling events. Or not doubling, quadrupling events. So if you have 7 quadrupling events, that means that you'll have to multiply by 4 7 times. Now you can express this by doing 4 to the 7th power. And you want to, of course, start your starting point, which is just 3 cells. And that's choice A. So choice A will give the number sentence. All right, and here's the summary for this page. All right, next for number 17, for what value of n does 2n plus 5 times n minus 5 is equal to 2n minus 7 times n minus 3? So here you have to FOIL both sides. You have 2n squared minus 10n plus 5n minus 25. You FOIL, and that's 2n squared minus 5n minus 25. Then for the other piece, again, you do the same thing. I have the FOIL, and this will be equal to 2n squared minus 6n minus 7n plus 21. And if you combine the middle two, that's 2n squared minus 13n plus 21. So here you actually have 2n squared on both sides. So you can just subtract that, and that's gone. So you just have negative 13n plus 21 is equal to negative 5n minus 25. So from here, you can add 13n to both sides and add 25 to both sides. So you get 46 is equal to 8n, and here you can divide both sides by 8. You get n is equal to 23 over 4 when you simplify by divided by 2. That's choice A. So here the key is just foiling, or first, outer, inner, last. And then you'll get 23 over 4 as the answer. All right, next for number 18. Triangle ABC is equilateral and has an area of 1 3/5. Point D is the midpoint of side AB. Point E is the midpoint of side BC. And point F is the midpoint of side AC. What is the area of parallelogram DECF? So you have an equilateral triangle. And the area is 1 3/5. Now, for this equilateral triangle, you can label it A, B, and C. D is the midpoint of AB. So D would be over here. E is the midpoint of BC. And F is the midpoint of side AC. And you want to know the area parallelogram DECF. That is this piece here. Now, because you have an equilateral triangle, you can just split this up into four smaller equilateral triangles. So 1 3/5 you can turn into an improper fraction for 8/5. And that represents a total. If each of these 4 pieces are equal, you can also just divide this by 4. So that's really multiplying once you do KCF. That's 8/5 times 1/4. And that'll give you 2/5. So that means that each of these smaller squares is 2/5. And you can always check your work. 2/5 times 4 is equal to 8/5, which is total. Now this parallelogram takes up 2 of those triangles. So that's going to be 4/5 for the area, choice C. So fortunate for number 18, you have an equilateral triangle, which means all the sides are equal. So you're going to be able to cut this into equal pieces. All right, next for number 19, at a car dealership, each of the 3 cars must be parked in one of the 6 adjacent parking spaces, provided that there is exactly 1 empty parking space between any 2 occupied spaces. How many ways can 3 cars be arranged in these 6 spaces? So you have 3 cars, you don't know what they are, so let's call them ABC. And there are 6 spots. And now there needs to be 1 spot that's empty in between. So if, let's say, you don't know, you have any, if you start here, you want to skip those spots. So here you have a couple of options. Specifically, you have 3 options. And then for the second spot, you have 2 options left. And for the last one, you just have 1. And if you multiply, that would be 6. So this is your counting principle. But that's for, that's if you put a car in the first spot. If you make the first spot empty, then you have the same 3, 2, 1 for those positions, and that's another 6. So in total, you have choice C, 12 options. So number 19, just a variation of the counting principle, really helps you draw a diagram. Next, for number 20, the circumference of circle M is 2 times the circumference of circle N. What is the ratio of 1/3 of the area of circle M to 1/4 of the area of circle N? All right, so you have two circles, and you don't know the radii, so let's call it A and B. Now, the circumference of circle M, so we can call this one the larger one circle M, the smaller one circle N. Circumference is 2 pi r. So the circumference here is 2 times pi times b, and the circumference for the smaller circle is 2 times pi times a. And we know m is 2 times circle n circumference. So you take the smaller number, you double it, and that's equal to the bigger number. So 2 pi b is equal to 2 times 2 pi a. Or 4 pi a is equal to 2 pi b. And divide by 2 pi on both sides. That's going to be equal to 2a to be equal to b. Now you want to know the ratio of 1/3 of the circle M to 1/4 of the area of circle N. Now, area is pi r squared. So for circle A, the area will be pi times a squared. For circle B, the area will be pi times b squared. Now, for circle N, you have to multiply by 1/4. And for circle B, you multiply by 1/3. Or circle M. And you want to know the ratio of the larger one to the smaller one. So the ratio is 1/3 pi b squared to 1/4 pi a squared. So the first things first, the pi's can cancel out. And then you'll have to do a substitution. You know that b is equal to 2 times a. So I have to replace b with 2a. Right there. So they'll give you 1/3 times 2a squared, in parentheses, squared, and 1/4 a squared. So from here, you have to distribute the exponent of 2. And that'll give you 1/3 times 2 squared, or 4a squared, divided by 1/4 of a squared. The a squared get canceled out, and you have 1/3 times 4, and you're dividing by 1/4, because this really means divide. So 1/3 times 4 is really just 4/3, divided by 1/4, and when you do keep change flip, you have 4/3 times 4/1, or 16/3. So that's choice A, 16/3. So here for number 20, the key was to use these two formulas. Circumference is 2 pi r, area is pi r squared, and you have set up a couple of equations for both the area and the circumference. All right, and here's the summary for this page. All right, for number 1, Andy and Bob are picking apples. Andy picks 16 apples per hour, and Bob picks 10 apples an hour. In 30 minutes, how many more apples has Andy picked than Bob? So Andy will be 16 in 1 hour. So 30 minutes is half of that. So that's going to be 8 apples in half an hour. Now for Bob, he picks 10 apples in 1 hour. In 30 minutes, that's half, which is only going to be 5. So how many more has Andy picked? Well, Andy picked 8. Bob picked 5. So 8 minus 5. Choice A, 3. All right, for number 2, if an unprime number is an integer whose only factors other than 1 and itself are prime, which of the following is an unprime number? So you have a whole number where the only factors other than 1 and itself are prime. So you list out all the factors for each of these. So 18, you have 1, 18, 2, 9, 3, 6. So you eliminate one in itself. These aren't all prime, so this is wrong. For 20, you have 1, 20, 2, 10, and 4 and 5. Again, you eliminate 1 and 10. These are not prime either. For 22, you have 1 and 22, and 2 and 11. You cross out 1 and 22, and it turns out 2 and 11, they are all prime. So the answer is choice C. For number 3, which of the following numbers, when added to the set above, which contains 1, 2, 3, 6, 8, and 12, would make the average of the new set equal to the median of the new set? So the median right now here you have to add a number to it. So the two keywords here are the average and the median. So the median is the middle number, and the average is just the total divided by the number of data. So here, if you look at all the choices, well, right now the median is kind of in between 3 and 6. But if you add a number that's 6 or greater, that will actually cause the median to be always going to be 6. Because if you add a number that's 6 or over here in any of those spots, that would make 6 become the median. So you really just want an average of 6. So in order to get an average of 6, you'll have to do a total divided by, will be now 7 numbers, because you're putting another number somewhere in here. And that is equal to 6. So that means that if you multiply both sides by 7, you get that the total has to be equal to 42. So right now we have 1 plus 2 plus 3, that's equal to 6. That's equal to 20. That's another 6. So right now the total is equal to 32. Well, to go from 32 to 42, you have to add 10. So the answer has to be choice C. Here, if you check your work, notice that if you start crossing out, 6 is in the middle, and if you add everything up, you have that 32 plus a 10, which becomes 42, and 42 over 7 is equal to 6. So the median is equal to the average. All right, next for question number 4. A is in the center of the circle, inscribed in a circle B, C, D, E. If the area of a circle is 121 pi, what's the length of CE? So area is the keyword here. Area, remember, is pi r squared, and set that equal to 121 pi. If you divide both sides by pi, you get that r squared is equal to 121. And from here, you can do the square root on both sides, and you get that r is equal to 11. So that's the radius. And you want to know the length of CE. Well, if the radius is equal to 11, you know that the side of the square is going to be equal to 2 times 11, or 22. And CE turns out to be the diagonal of a 45, 45, 90 special right triangle. So the ratios are going to be XX, x root 2. In this case, it's going to be 22, 22, and 22 root 2. So you should memorize this 45, 45, 90 special right triangle. You can also use Pythagorean theorem, but that does take a while longer. So the answer is choice D. Next for number 5, tiles marked 1 to 1,000 are placed in a bag. If a tile is chosen at random, what's the probability that the tile number is even and a multiple of 5? So even and a multiple of 5 means that it has to be a multiple of 10. That's because even numbers are multiples of 2. And you want to be a multiple of 2 and 5? Well, 2 times 5 is equal to 10. So to figure out how many multiples of 10 are from 1 to 1,000, you can just do 1,000 divided by 10. That's equal to 100. So there are 100 multiples of 10. So that's the part. Because probability is just part over whole. And the part, you want multiples of 10. So there's 100. And there's 1,000 total. 100 over 1,000 is 1/10. That's choice A. Next, for number 6, an amusement park ride has an elevator that brings riders to the top of the tower. Riders step off the elevator onto a slide, which is a straight line from the top of the tower to the level ground. The base of the slide is 400 feet from the base of the tower, and the length of the slide is 500 feet. So the tower, the base is 400 feet, and the slide is 500 feet. Now, if the elevator rises at a rate of 10 feet per second, how many seconds does the elevator take to rise on the ground to the top? So this is your 30, 40, or 300, 400, 500 special right triangle, just a 3, 4, 5 that you've seen before, is that Pythagorean triplet. So in this 3, 4, 5 triangle, everything just multiplied by 100. But then it turns into a distance equals rate times time question, because you have a rate of 10 feet per second, and the distance is 300 feet. So the time is going to be distance divided by rate, because time is distance over rate, and that's 300 divided by 10, or 30 seconds. And that's choice A. All right, next for number 7, when S is increased by 100%, the results are. If S is 20% of T and the ratio of T to U is 5 to 4, what's the ratio of R to U? So increase by 100% means you take S plus 100% of S, and that's equal to R. So 100% of S is just S. So if you add 100%, it really just turns into S plus S, or 2S, which is equal to R. So R is 2 times S. Now, S is 20% of T as well. So that's the next equation. So S is 20%, or 1/5 of T. So if you multiply both sides by 5, you know that 5S is equal to T. So T is equal to 5 times S. Now the ratio of T to U, and ratio means divide, so T over U is equal to 5 over 4. Cross multiply that, you got 4T is equal to 5U. And you want to know the ratio of R to U. So here, you know that R is equal to 2 times S, and 5 times S is equal to T. So if you take these two, you know R is equal to 2S. You want S's to be the same. So you have 2S versus 5S. The LCD is, or the LCM rather, is 10. So if you multiply both sides by 5, you know that 5R will have to be 10S. And for the second equation, you have 5S is equal to T. If you multiply both sides by 2, you'll get 10S is equal to 2T. So you know that 5R is equal to 10S is equal to 2T. So now you have 5R is equal to 2T. But you know that 4T is equal to 5U. So if you take 5R is equal to 2T, if you double both sides, you get that 10R is equal to 4T. But you know that 4T is also equal to 5U. So 10R has to be equal to 5U then. And you want the ratio of R to U. That means you want R in the numerator, U in the denominator. So you want to divide by U and divide both sides by 10. You got R over U is equal to 5 over 10, or 1/2. So the answer is choice C. So for number 7, you just have to do a lot of equations. Specifically, you have to turn the word sentence to a number sentence, and then just use the lowest common multiples to equate these equations together and just do a bunch of substitutions. All right, and here's the summary for this page. All right, next for number 8, the figure above shows a circle tangent to line RS at point R. If O is the center of a circle and RS is equal to 4, what's the radius of the circle? All right, so tangent means it touches at one point, and it'll make a 90-degree angle. So you know that has to be 90 degrees. So this is a 30, 60, 90 special right triangle. And here, RS has to be 4. And for this 30, 60, 90 right triangle, the sides are in a ratio of x, 2x, and x root 3. So the x side corresponds with the 4. So if x corresponds with the 4, 2x will be 8, and x root 3 will be equal to 4 root 3. So the radius of the circle will be that 4 root 3, choice C. So again, this is a 30, 60, 90 special right triangle. That is one of the specialized right triangles that helps you out. All right, next for number 9, if a and b are integers, so they're whole numbers, and the product is negative 10, what's the greatest possible value for a minus b? If you want to maximize this, one thing that you can do is you know that if you subtract a negative number, it turns into a positive. So you want a positive subtract by a negative. So if you think about the products of negative 10, the most negative factor will be negative 10, and one of them could be 1. So if a is equal to 1, b is equal to negative 10, this will be 1 minus negative 10, which will be 11, which is definitely the largest. There's no way we can get 25 because 25 doesn't factor in at all. The biggest factor of 10, of course, is just 10 and 1. So there's no way we can get 25. So the answer has to be choice D. Next for number 10, after the first term in the sequence, the ratio of each term to the preceding term is x. The first term is y. What is the third term? The first term is y. The ratio of each term to the preceding is x. So there's a common ratio, and that's called a geometric sequence, where you keep multiplying a number. In this case, it's x. So times x, so the next term will be xy, and it times x again, and you get x squared times y. And that's the third term, choice B. Okay, next for number 11, Marvin has a collection of baseball cards, each just depicting a single player. If there are 420 cards in the collection and a randomly drawn card has a probability of 5/6 of depicting the picture, how many of the baseball cards in the collection depict pitchers? So 5/6 is the probability, and that's the total. So we have the part of the whole, and that really just turns into 5/6 times 420, or 420 over 1. It helps if you cross simplify. 42 and 6 cancel out for 70, and 70 times 5 is 350. So there are 350 pitchers in the collection. All right, next for number 12, if 5p plus 5 is equal to p plus 12, then p is equal to, so here if you subtract 5 from both sides, you get 5p is equal to p plus 7. And then if you subtract p from both sides, you get that 4p is equal to 7. And if you divide by 4, you get that p is equal to 7 over 4. Now, you can actually put mixed numbers, so just FYI for that part for the SATs. All right, and here is the summary for this page. All right, next. For number 13, if m plus n is equal to 11 and 3m minus 2n is equal to 23, what's the value of 12m minus 3n? So you have these two equations, and you stack them up, and you tried to do a variation of elimination. You actually can see you get 4m minus n is equal to 34. And that is actually really important because to turn that equation into the one you want, you just multiply by 3 on both sides. So multiply everything by 3, you'll get 12m minus 3n, which is exactly what you want. And 34 times 3 is 102. So the answer is 102 here. Next, for number 14, in the figure above, ABDE is a parallelogram, and the length of AE is 24. Now, if the area of triangle BCE is 3 times the area of a triangle CDE, and CE is the height, what's the length of BC? All right, so here ABDE is a parallelogram, so opposite sides are equal, so that means that the base, B or BD, is also going to be 24. Now the area of BCE, so that piece here, is 3 times the area of a triangle CDE. So that little tiny piece here. And CE is the height. So if we call the height H, the area will be 1/2 the base times height. For triangle CDE, you also have the area is 1/2 base. This base, so we can call this piece, let's say capital B. This piece would be lowercase b. Now the area of triangle BCE is 3 times this, or rather the smaller triangle times 3 is equal to the larger one. So that means that 1/2 lowercase b times h, multiply this by 3, will be equal to the larger triangle's height. So the larger triangle is equal to 3/2 b times h. And if you add this together, you get the total. So 3/2 plus 1/2 will be just 2 times BH will be equal to 24. So that BH will have to be equal to 12. And to figure out the length of BC, you essentially know that since the height is the same, and you have 1 and 3, because it's the 3 times the area, you can just split 24 into 4 pieces, because you have one piece that's 3b, the other piece is just 1b. So there's 4 equal pieces, and each piece will be equal to 6. That means that this piece will be 6, this piece will be 18. So the length of BC will then have to be 18. You essentially split 24 into 2 pieces. One of them has to be 3 times bigger than the other one. So this would be 6 and 18, and they have to add up to 24. All right, next to number 15, the 5 numbers shown above are repeated indefinitely, so forever, in that order to form a sequence. What's the product of the first 20 terms of the sequence? All right, so you want to multiply the first 20 terms. So if you look at each of these sets, you multiply the set. Well, 1/2 and 2 cancels out. 3 times 1 is just 3, because you can just ignore the 1. And you just have to multiply by the -1. So that's going to be equal to -3. So every 5 numbers, you get a product is equal to -3. So since you have 20 terms, you'll have 4 of those, because there are 4 5s in 20 numbers. So that means you have to do -3 times -3 times -3 times -3. And now each of these will be equal to 9, and 9 times 9 is equal to 81. Because negative times negative turns into positive. That's how you follow the pattern for number 15. All right, for 16, you have the shape. The length of BC is 3. AB is equal to DE, so it's also equal to 12. What's the perimeter of figure ABCDE shown above? So if you connect the opposite side here, since they're both equal to 12, you can actually make a rectangle. Now BC is equal to 3, so you have a right triangle on top. That has to be 3 for 5. So to get the perimeter, you have 3 plus 4, which is 7, plus 12 and 12, which is 24, plus another 5. All right, so 7 plus 4 is 11, plus 5 is 16. So you get a perimeter of 36. All right, next for number 17. Alberto's trying to remember the last 4 digits of his friend's phone number. He can recall the first digit, but he's forgotten the last 3, each from 0 to 9. How many different arrangements of 3 digits are there for the forgotten portion? So this is your counting principle. And you just write out the 3 spots that are available and how many choices you have for each. So from 0 to 9, there are 10 digits. So because they could repeat each of these spots, you can have 10 potential numbers. So you just have to do 10 times 10 times 10 for the counting principle. That means there are 1,000 numbers from 0, 0, 1, 0, 0, or 0, 0, 0 to 0, 0, 1, all the way down to 999. So there will be 1,000 numbers, including 0, 0, 0. All right, and here's the summary for this page. All right, next for number 18. In the figure above, points G, H, and I in the xy plane have coordinates 0, 2, 2, 8, and 8, n respectively. Now GH is equal to HI. What's the value of n? So here it helps if you draw triangles to see the rise and run. From 0 to 2, that will give you a length of 2. So this triangle would be the same. And then from the y value of 2 to 8, that's a difference of 6. So that has to be the same here because they are equal. These triangles would have to be congruent. So here, you know that at this 2, the x coordinate plus the 6 will become 8. So now you have to do the 8. This time you want a minus 2. That'll give you an n of 6. So you have to go down for this triangle. All right, next for number 19. On Bindi's guitar, the frequency of a vibrating string varies inversely as the length of the string. When a guitar string of S inches in length that vibrates at a frequency of 80 cycles per second is shortened to 6 inches in length, it vibrates at a frequency of 120 cycles per second. What's the value of S? So the key here is an inverse relationship, which means as X goes up, Y goes down. It's to go in opposite directions. It's not directly proportional. So that means that here you have S inches, and that will be 80 cycles. You shorten it to just 6 inches. It'll vibrate at a frequency of 120 cycles. So if you go from 80 to 120, you have to multiply by 1.5. Numbers always multiplying and dividing. You can do 120 divided by 80 to figure that out. And 12 over 8 simplifies if you divide by 4 to get 3 over 2. And that's where you get the 1.5 from. So if you multiply by 1.5 on the right, you're going to have to do the inverse or divide by 1.5. So these have to be opposites. So something divided, so S divided by 1.5 is equal to 6. That means you'll have to, you can also rewrite this S over 1.5 is equal to 6. That means you'll have to multiply by 1.5 on both sides. And 6 times 1.5 will be equal to 9. So S will be equal to 9 inches. So if you shorten the length from 9 inches to 6, the cycles actually increase from 80 to 120. All right, next for number 20. At Uriah's coffee shop, the amount of ground coffee beans left in stock on a given day is a function of the amount of coffee sold that day. So if C is the number of cups sold, Z of C is the number of ounces of ground coffee that's been left in the stock. So then Z of C is equal to 50 minus C over 7. This is your function, or your input-output machine. So you want to figure out, well, how many cups of coffees will Uriah have sold when he runs out of coffee, ground coffee beans. So runs out means you have 0. So no more in stock, which means 0. So you want to set Z of C, which represents the number of ounces of coffee left in stock. This has to be equal to 0. So Z of C, you know, is 50 minus C over 7. So you set this equal to 0, and you want to solve. You can add C over 7 to both sides to get 50 is equal to C over 7. And then you multiply by 7 from both sides. And you get 7 times 50, which will be 350, is equal to C. So after selling 350 cups, you will have run out of coffee. Now, you can always check your work. If you do Z of 350, that would be 50 minus 350 over 7, or 50 minus 50, which is equal to 0. All right, and here's the summary for the last page. All right, thank you everyone for joining me today. Enjoy the rest of the day, and I will talk to you guys next time. All right, bye everyone.